Hello guys, welcome to our YouTube channel. Today we are going to discuss about the Flash ADC or the parallel ADC. It is used for converting the n-bit data by using a single clock pulse. This is the advantage of the Flash ADC, that is other types of ADCs requires multiple clock pulses, but in this type of ADC only a single clock pulse is sufficient for converting the n-bit data, that is the analog signal, into the digital signal. Hence, it is used in the fastest application where the speed matters. I mean, when the application needs to be operated at the fastest speed. Now, let us see how can we design the circuit for the Flash ADC. First, you have to keep in mind that we need 2 power n resistors. N is the number of bits, how many bits you want to convert, and 2 power n minus 1 comparator or the op amps are required. For example, I am considering 3-bit operation now. For 3-bit 2 power n, 8 resistors of equal value R is required as shown here, and 2 power n minus 1, that is 7 comparators or the op amps are required. The analog input Vin is provided to the non-inverting terminal of the op amps as shown here, and V reference is segregated into 2 power n minus 1 branches as shown here, and the values of the V reference will be 7 by 8, 6 by 8 times V reference at these branches, and here it is grounded, and the output of this op amps, that is D7 to D1, is given to the priority encoder. D0 is always grounded. The priority encoder which have XOR and the diodes internally, according to the internal logic, it gives the equivalent value of this 8-bit into the 3-bit digital data as shown here. Now let us see how exactly this working takes place. Generally we have this analog input given through here, which is checked with the reference value which were given here. Based on the analog signal and the reference value, the comparator will compare the V in and the V reference value. If V in is greater than V reference, then the output of this comparator, that is here D7, will be 1. Output will be of logic 1. If V in is less than V reference, then the output is considered to be 0, that is any logic 0. So accordingly, the values will enter into the priority encoder. However, D0 is always 0, and based on that given value of V reference, it will compare and then give the output. For example, if V reference is 8 volt and V in is also 8 volt, here the value of resistance, here 8 will get cancelled, and this will be, here it will be 7 and 8, it will compare 8. Okay, V in is greater than V reference, so the output D7 will be logic high. Similarly, here also 6, 8 is greater than 6 volt, so the logic will be high. Similarly, all 1, 1, 1 will get, and this will be 0. In such ways we have to solve this. The advantage of this type of ADC is it is considered to be the fastest ADC because as it requires only one clock signal for the converting, that is all these operations, that is the output of the comparators are obtained parallelly for only one single clock pulse. Hence it is considered as the fastest ADC. And considering the disadvantages, as you can see, it is the complexity of the circuit, bulky circuits, and hence the cost also increases. If you are preparing for the gate examinations, you have to remember this number, that is 2 power n resistors are required to design a n-bit ADC, and 2 power n minus 1 comparators or operational amplifiers are required for designing the n-bit Flash ADC. These numbers you should remember, it is very important formula. So these types of questions is repeated in the gate examination. So that's all about the Flash ADC, and thank you for watching.